Machine learning has revolutionized the business world and is helping us building sophisticated applications to solve challenging business problems. Using supervised and unsupervised machine learning models, you can solve problems using classification and regression and clustering algorithm. In this video, we will discuss a supervised machine learning algorithm in Python called Logistic Regression. Logistic regression can be used to solve both classification and regression problems. What is supervised learning? In supervised machine learning, machines are trained using labeled data, also known as training data, to predict results. Here, labeled data refers to a group of data have been tagged with one or more names and the data is already known to the machine. In the real world, supervised machine learning can be used for image object detection, predictive analytics, spam detection, and customer sentiment analysis, and many more. Supervised learning problems can be further classified into regression and classification problems. In classification problem, that output variable is a category such as red or blue, disease or no disease, true or false, and many other. In regression problem, the output variable is the real continuous value such as dollars or weight. So now let's move forward and have a look on what is logistic regression. Logistic regression is a statistical technique for creating machine learning models with a binary of dependent variable. It describes the relationship between two variables, dependent variable and or independent variable, which can be nominal, ordinal, or interval types. This method employs the logistic function, also called the sigmoid function, with output values constrained between 0 or 1. Let's take an example of logistic function. So we can use to find the probability of a vehicle breaking down, depending on how many years it has been used since it was serviced last. So here is how you can interpret the result from the graph to decide whether the vehicle will break down or not. So moving forward, let's see advantages of logistic regression algorithm. The first one is logistic regression performs better when the data is linearly separable. The second one is it does not require too many computational resources as it's highly interpretable. The third one is there is no problem scaling in the input features. It does not require tuning. The fourth one is it is easy to implement and train a model using logistic regression. Now moving forward, let's see how does a logistic regression algorithm work. Let's take an example. An organization wants to determine an employee salary increase based on their performance. For this purpose, a logistic regression algorithm will help them decide. Plotting a regression line by considering the employee performance as the independent variable and the salary increase as the dependent variable will make their task easier. So now what if the organization wants to know whether an employee would get a promotion based or not? So the linear graph won't be suitable in this case. As such as we clip at the line at 0 and 1 and convert it into a sigmoid curve S curve. So based on threshold values, the organization can decide whether an employee will get a salary increase or not. So there are some mathematical functions which can help you on finding logistic regression analysis. So these are some mathematical functions you can use in logistic regression analysis. So LR function. Logistic regression is a statistical model that uses the logistic function or logit function in mathematics as the equation between x and y. So the logit function maps y as a sigmoid function. Logistic regression with multiple independent variables. In many cases, multiple explanatory variables affect the value of the dependent variable. So to model such input dataset, logistic regression formulas assume a linear relationship between a different independent variables. So you can modify the sigmoid function and compute the final output. And the last one is the logit function. The logit function, you can also say the log odds. The logit model can also determine the ratio of success to failure or log odds. So moving forward, let's see some application of logistic function. I repeat. So moving forward, let's see some application of logistic regression. The first one is banking. Using the logistic regression algorithms, banks can predict whether a customer would default on loans or not. The second one is to predict the weather condition or a certain place, sunny, windy, rainy, or humid. You can predict from logistic regression. The third one is e-commerce. E-commerce companies can identify buyers if they are likely to purchase a certain product. The fourth one is companies can predict whether they will gain or lose money in the next quarter, year or month based on their current performance. So now moving forward, let's jump into our Jupyter notebook to implement logistic regression demo. So now here we will do loan prediction using logistic regression. So first I will change the name, loan prediction using logistic regression, right? So we will import some major libraries like NumPy, import numpy as np, then import pandas as pd, then import matplotlib.pyplot as plt for the graphs and all. Then we will import cbon as sns. So moving forward, we will import one dataset pd.read_csv, then logfile.csv. Okay, spelling mistake. Yeah. Okay. Logfile.csv. Okay, let me check the file name first. So here file name is lone file, just lone file only. So moving forward, we will do some function. Let's check. So this is our dataset. So in this there are like multiple columns: name, loan ID, gender, married, dependents, education, this. Then let's check the info of the dataset. df.info. So as you can see, so we have 13 columns, right? Total 13 columns, and the column type is this object, float, and object. Okay, the memory usage and all. Once again, let's check how many rows. df.shape. So as you can see, we have 614 rows and 13 columns present in our dataset. Okay, we'll check using describe as well. Yes, so this is the count of the particular column, then mean, then standard deviation, minimum, that 25% of particular column. Okay, the maximum value, the 75% of that particular column value. Okay, let's check how many null values are there. So for that, we'll write is null, because first we have to sort our data set for the better predictions. Okay, so loan ID don't have any null value, gender have, married have, okay, right? So now let's do some data cleaning here. For data cleaning, we'll write df loan amount equals to df loan amount dot fill na. Okay, df loan amount dot mean. Okay, it's df, right? So for credit history, we'll check df then credit history equals to df credit history dot fill na. So I am filling the particular cells with the median or mean values. Okay, then df credit history again, history dot median, right? So now again let's check is null dot sum. Okay, fine. Credit history now 0. As you can see here, you can see the credit history is 50 null values were there, now 0. And one more loan amount, okay, 22. Now loan amount is 0. So df dot drop na place equals to true. Then now df dot shape. So now as you can see, we have dropped all the null values rows. As you can see, the 542 here, before it was 614, right? So now let's moving forward, we will do some EDA, okay, some data representation. So here what we will do, we will plot some graphs, right? So I will write here plt dot figure, then figure size equals to 100, 50, then sns dot set font scale equals to 5, and plt dot subplot 331, sns dot count plot, then df where I need gender, then hue will be df, then loan status, right? So I will do the same for the married and the education, then the self-employed, then the property area, right? So I can copy this and paste it here, right? One more I need. Okay, then I will change the name. But I need married 332, 333 for education, 34 for self-employed, then for property area, right? Here I will write some. Okay, let's run it. It's loading. Some error is there. Okay, G is capital here. So now as you can see, these are some bar graph, like how many married are there, loan status yes or no. The blue one is yes. Okay, for the education, for the self-employed. So these are some warnings, you can ignore them, right? So moving forward, we will check some loan status. So I will write here, I want only loan status dot replace y to 1 and n to 0. Okay, so later it will be good to check, 1 in place equals to true. Okay, same for no status dot replace n, 0, in place equals to true. Status S is capital here. Cancel. It is nothing, just a typo mistake. Okay. So here I will write df, then loan status, then value counts. Okay. So yes R376 and the no R166, right? So we'll check with the gender, married and the dependents. Okay, so for that I will write df dot gender equals to df dot gender, G is capital here, dot map, then male is 1, female is 0, right? Then I will write df gender dot value counts. Okay, so now I gave male to 1 and female to 0. Okay, so this is the gender count, right? So I will do this for married as well as the dependents. Okay, for all the education, self-employed, property area. Okay, so what we can do, we can just copy it, paste it here, and we can change, right? For the married, yes to 1 and no to 0. So let me do it fast for you and then I will get back to you. So as you can see, we have done with all the value counts here, like property area, self-employed, education, dependents, married. Okay, we have all the counts. So now let's see the loan amount value count. Loan amount dot value counts. Okay, so this is the loan amount value count. Then we'll check the loan amount value term. For that I will write loan amount term dot value counts, right? Then let's check the credit history, which is very important factor for the loan. Credit history dot value counts. Okay. Right. So now let's check df dot head. So now as you can see, we have this. See, 1 means male. Here you can see we gave married, the gender male equals to 1, then female is 0. So this ID is male ID, right? Then 0 1 we have all gave here, right? 0 1 0 1, right? If the guy is graduate, so 1, not graduate, so 0, self-employed is yes or no, like that, right? So now we'll do the train test split. Okay, for that I will write from sklearn dot model selection import train test split, then from sklearn dot linear model import logistic regression. Okay, then I will write from sklearn import matrix. Okay, we run it. So here I will assign x equals to df dot ilog and 1 ratio 542 rows, then from 1 to 12 columns dot values, then y equals to df dot ilog, the same, okay, 1 to 542 rows, then column dot values. Okay, so here I will do x train comma x test comma y train comma y test equals to train test split, then x comma y comma test size equals to 0.3. 0.3 means 70% will be the training data and the 30% will be the testing data, right? Comma random state equals to 0. Got it? So now let's do the logistic regression. Let's apply model equals to logistic regression, then model dot fit x train comma y train, then lr underscore prediction equals to model dot predict, then x test, right? Then print logistic regression accuracy equals to comma matrix dot accuracy underscore score, then I will write here LR predictions comma y test, right? So as you can see, we have the accuracy of almost 79%, or you can say 78%, right? So now let's see the predicted values. So for that, print y prediction, predicted values, comma lr prediction. Okay, then print y test, y underscore test. So as you can see, so these are some predicting values. Like 1 means that guy or girl have the loan. Okay, loan status is yes, loan prediction status is yes. Then 0 means no, right? And the testing we did the here 0. Okay, the predicted value is 1, right? So these are some prediction values and the testing values. So this is how you can do loan prediction using logistic regression. Okay, so we have come to end of this video. If you want this full code, you can comment down below, and if you want this file, loan file, so you can check out from the description box below. And if you have any queries, so please comment down in the box. We will reach out to you as soon as possible.